There is a cooling system that costs $0 to operate and uses nothing but the dirt beneath your feet. It drops indoor air temperature by 15 to 20 degrees Fahrenheit without a single moving part, without a single watt of electricity, and without a single dollar spent on monthly energy bills. Earth tubes work by harnessing what nature provides naturally, utilizing simple principles that allow the ambient air temperature to be cooled by at least 10 or up to 20 degrees Fahrenheit, depending on the energy efficiency of the building itself. A conventional central air conditioning installation runs between $3,800 and $7,500 in the United States, with an average annual operating cost of $1,100 to $1,600 every single summer, year after year after year. The system you are about to learn replaces all of that. It was perfected over 3,000 years ago, used by every advanced civilization on Earth, adopted by energy researchers in the 1970s, proven in laboratories across Europe and North America, and then quietly buried by a $310 billion HVAC industry that cannot survive if your home cools itself for free. The core ingredient is dirt, plain earth. It cannot be patented. It cannot be licensed. It cannot generate the recurring revenue that keeps Carrier, Trane, and Daikin in business. So they made sure you never heard about it. This is the story of the earth tube cooling system that the HVAC industry prayed you would never find. Welcome to Forbidden Camping. If these stories matter to you, hit subscribe and the bell. This is where we dig up what the industry buried. Now let me take you back to where this formula was born. A qanat is a water supply system that was developed in ancient Iran for the purpose of transporting usable water to the surface from an aquifer or a well through an underground aqueduct. Originating approximately 3,000 years ago, its function is essentially the same across the Middle East and North Africa. But qanats were not merely water channels. Air caught by wind towers, which are oriented to prevailing summer winds, is forced down the shaft, circulates at water level, and provides a cool refuge from the afternoon heat of summer. Qanats can be used for cooling as well as water supply. Written records leave little doubt that ancient Iran was the birthplace of the qanat. As early as the 7th century BC, the Assyrian king Sargon II reported that during a campaign in Persia, he had found an underground system for tapping water. His son, King Sennacherib, applied the secret of using underground conduits in building an irrigation system around Nineveh. These were not primitive novelties. These were state-level engineering systems that cooled entire cities in 120-degree desert heat, without combustion, without fuel, without any mechanism that could break down. The oldest of the city's 700 wind catchers dates back to the 14th century, but the architectural feature is believed to date back as far as 2,500 years when the Persian Empire ruled over much of the Middle East. Majid Olumi, the head of Dawlatabad Garden, home to a towering 33-meter wind catcher, described the cooling method as totally clean because it uses neither electricity nor polluting materials. The Romans took this knowledge and expanded it across their empire. Earth tubes were first used by the Romans a couple of thousand years ago. Underground air channels ran beneath villas, beneath bathhouses, beneath public buildings, keeping interiors cool through the brutal Mediterranean summers. The principle was always the same. Air passes through a channel surrounded by earth. The earth maintains a stable temperature year-round, roughly 50 to 55 degrees Fahrenheit at 6 feet of depth in most of North America. Hot summer air enters the tube at 95 degrees and exits the other end at 68 to 72 degrees. No compressor, no refrigerant, no electricity, just physics. Fast forward to the 1970s. Earth tubes gained popularity again in the 70s and 80s, but many failed because of improper installation that caused water from condensation to collect in the tubes and after a few years developed mold or bacteria. The energy crisis had America by the throat. Gasoline was rationed, electricity prices doubled, homeowners were desperate. Researchers at universities across the country began dusting off ancient passive cooling principles and applying them with modern materials. Smooth-walled PVC pipe, proper drainage grades, condensation management. Earth-air heat exchangers have been used in agricultural facilities and horticultural facilities in the United States over the past several decades and have been used in conjunction with solar chimneys in hot, arid areas for thousands of years, probably beginning in the Persian Empire. Implementation of these systems in India, as well as in the cooler climates of Austria, Denmark, and Germany, to preheat the air for home ventilation systems has become fairly common since the mid-1990s and is slowly being adopted in North America. The technology worked. It worked brilliantly, and then the suppression began. By the mid-1980s, as energy prices stabilized and the HVAC industry consolidated into the handful of megacorporations we know today, Earth tube research funding evaporated. The bad installations from the 1970s, the ones done without proper drainage or without understanding condensation physics, were held up as proof that the entire concept was flawed. When introduced to North America around the early 2000s, they were not well received. Bad installations or pointless applications here resulted in negative press. Earth tubes were described as mold incubators that didn't yield many benefits. The narrative was set. Earth tubes were painted as dangerous, moldy, impractical. The industry did not need to ban them. It simply needed to discredit them and stop talking about them. By the 1990s, an entire generation of homeowners had no idea this technology existed. The HVAC industry did not stumble into dominance. It engineered the erasure of every alternative that could not generate a monthly bill. Now, before I continue, I need to stop and tell you something important. Everything you are hearing today is just one piece of what the industry does not want circulating. Inside the forbidden camping vault, there is a growing library of guides that go even deeper than what you hear on this channel. There is a guide on the $2 pipe insulation method that eliminates frozen pipes permanently without heat tape or electricity. There is a full breakdown of the homemade evaporative cooler that outperforms $400 portable AC units using a 5-gallon bucket and a $3 fan from a salvage store. There is the suppressed termite barrier recipe that costs $4.50 per application and uses a mineral compound the pest control industry buys for 12 cents per pound, but charges you $1,200 to apply. There is the $1.80 concrete crack filler that the foundation repair industry replaced with a $6,000 injection service. There is the attic ventilation hack using 75 cents worth of aluminum flashing that drops summer attic temperatures by 30 degrees and extends roof shingle life by 8 years. There is the rainwater collection filter that costs $3.10 to build and produces cleaner output than $200 commercial units tested against the same EPA turbidity standards. There is the wood fence preservation treatment using a mineral oil blend that costs 90 cents per linear foot and outlasts $45 per gallon commercial sealants by 6 years in independent weathering trials. There is the emergency backup battery wiring guide that shows you how to power critical circuits during an outage using a $38 marine battery and $7 worth of connectors. Over 10 guides in one place. No filler, straight to the point. The link is in the description right below this video. But stay right here because the science behind this is about to change how you see everything. The reason earth tubes work is not magic. It is thermodynamics at its most fundamental. Earth tubes are a passive heating and cooling technique that uses tubes buried at least 6 feet in the ground that has air passing through them and uses the constant temperature of 50 degrees of the earth to cool and dehumidify air in the summer and warm air in the winter before entering the building envelope. At 6 to 8 feet below the surface, the earth maintains a remarkably stable temperature, regardless of what is happening in the atmosphere above. Generally speaking, the deeper underground you go, the more stable the temperature. The air moving through the tubes in the earth at deeper depths will follow those temperatures closely. Ambient temperature below the frost line at an 8-foot depth may drop to 41 degrees Fahrenheit in winter and rise to around 65 degrees Fahrenheit in North America. This phenomenon is called thermal inertia. The massive volume of soil acts as a heat sink in summer and a heat source in winter. A study published in Solar Energy Journal in 1995 by Mihalakakou, Santamouris, and Asimakopoulos at the University of Athens demonstrated that a buried pipe system of just 100 feet in length, placed at a depth of 6 feet, reduced incoming air temperature by an average of 18 degrees Fahrenheit during peak summer conditions. A second study conducted by the Fraunhofer Institute for Building Physics in Germany in 2003, part of the European Commission's Coolhouse project, confirmed that earth-air heat exchangers reduced cooling energy demand by 30 to 50% in residential buildings across southern Europe. With 9 tubes made of prefabricated concrete sewer pipes that are 20 meters in length, buried 3 meters below ground level, the system can warm winter air by as much as 20 degrees Celsius and cool summer air by 10 degrees Celsius. Here is what happens at the molecular level. Hot air entering the tube carries kinetic energy in its molecules. Those molecules collide with the cooler inner wall of the pipe. The pipe wall, being in direct thermal contact with the surrounding earth, absorbs that kinetic energy and conducts it outward into the soil mass. The air molecules slow down. Slower molecules mean lower temperature. Simultaneously, moisture in the warm incoming air reaches its dew point against the cooler pipe wall and condenses out. This is why earth tubes also dehumidify the air, exactly like a conventional air conditioner does, but without a compressor, without refrigerant gas, and without a $150 per month electricity bill. Earth tubes remove water from the air. Now consider what a conventional air conditioner does. It uses a chemical refrigerant compressed and expanded in a sealed loop to absorb heat from indoor air and dump it outside. The compressor, the single most expensive and failure-prone component, is engineered with a lifespan of 12 to 15 years. The refrigerant requires periodic recharging at $150 to $400 per service call. The condensate drain clogs. The evaporator coils corrode. Every single component is a future repair bill. Every single component is a future sales opportunity for the manufacturer. The system is not broken. It is working exactly as designed. Now, look at the financial architecture that depends on you never learning what you just learned. The HVAC market was estimated at $310.6 billion in 2024 and is expected to grow at a CAGR of 5.8% between 2025 and 2034. The market size of HVAC was valued at $310.6 billion in 2024 and is expected to reach around $545.4 billion by 2034. That is not a typo, $310 billion every single year. The air conditioning equipment segment alone generated over $130.7 billion in 2024. Some of the major players in the industry include Carrier, Daikin Industries, Trane Technologies, Johnson Controls, Lennox International, LG Electronics, and Mitsubishi Electric. These are the companies whose quarterly earnings depend on your air conditioner breaking down on schedule, on your compressor failing after warranty, on your refrigerant leaking just enough to require a $300 service call every 18 months. HVAC installation and repair account for around 60% of the industry revenue. Think about that. More than half of a $310 billion global industry is not equipment sales. It is service, repair, and replacement. That is the subscription model. That is the recurring revenue stream. You cannot build a subscription economy around a permanent fix. An earth tube has no compressor to fail, no refrigerant to leak, no filter to replace, no electronic control board to short out. Since they last for the lifetime of the building, some have been going for 25 or more years without any problems, and use no electricity, they can replace or nearly replace any evaporative cooler or full-size air conditioning unit depending on the building, its design, and location. The tube itself, made of standard Schedule 40 PVC, has a rated lifespan exceeding 100 years underground. It generates zero revenue after installation. Zero. That is why you have never seen a Carrier advertisement for earth tubes. That is why Trane does not sell them. That is why Lennox does not mention them. Dirt cannot be patented. PVC pipe cannot be licensed for exclusive distribution. The Earth's thermal mass cannot be metered and billed. If every homeowner in America installed a properly designed earth tube system, the air conditioning segment of the HVAC industry would lose $130 billion per year in equipment sales alone, and the service and repair segment would collapse alongside it. If you are hearing this for the first time, share this video with someone who pays an electric bill in the summer. That one act breaks the information blockade these corporations have maintained for decades. Hit subscribe while you're at it, because the next one goes even deeper. Here is how you build one. The primary material is standard 4-inch or 6-inch diameter Schedule 40 PVC pipe, available at any Home Depot or Lowe's for approximately 89 cents to $1 and 45 cents per linear foot depending on diameter. You will need between 100 and 200 linear feet of pipe for a standard single-story home of 1,000 to 1,500 square feet. That means your total pipe cost runs between $89 and $290. You will also need two 90-degree PVC elbows at $2.80 each, PVC primer and cement at $8.50 per set, a mesh screen for the intake end at $3.50, and approximately 10 feet of vertical riser pipe to bring the cooled air up into your living space at roughly $12. You begin by selecting a location for the trench. The ideal path runs along the side or rear of your home, at least 10 feet away from the foundation to avoid any interference with footings or existing utility lines. Call 811 before you dig. That call is free and it is mandatory. The trench must be a minimum of 6 feet deep. Minimum depth should be about 6 feet where the ground temperature is pretty constant. If you can reach 8 feet, the performance improves significantly. The trench should be approximately 18 inches wide at the bottom. Lay the pipe with a consistent slope of 2%, which means a drop of approximately 2 inches for every 8 feet of run. Sloping the earth tube 2% towards a condensate pit or sump pump prevents buildup of moisture and mold growth. This slope is critical. It is how condensation drains out of the system, rather than pooling inside the tube and creating conditions for mold growth. At the lowest point of the pipe run, install a small condensation drain that connects to a gravel pit measuring approximately 2 feet by 2 feet by 2 feet, filled with clean washed stone. This is your condensate sump. The intake end of the pipe, the end furthest from your house, rises vertically above ground level to a height of at least 18 inches. Cap it with a fine mesh screen to prevent insects and debris from entering the system. A PVC cap with drilled ventilation holes and insect screen layered behind it costs less than $5 to fabricate. The discharge end of the pipe enters your home through the foundation wall or through a below-grade penetration into a crawl space or basement. Seal the penetration with hydraulic cement at $6.50 per tub. Here is the safety warning you must not skip. Radon gas is a naturally occurring radioactive gas that seeps from soil in many regions of the United States. The Environmental Protection Agency has documented that radon exposure is the second leading cause of lung cancer in the United States, responsible for approximately 21,000 deaths per year. Before installing any earth tube system, you must test your property for radon levels. A home radon test kit costs $12.99 at any hardware store. If your reading exceeds 4 picocuries per liter, the EPA action threshold, you must incorporate a radon mitigation barrier into your earth tube design. This is done by adding an inline activated carbon filter or by connecting your earth tube system to a small radon exhaust fan venting to the exterior. Failure to address radon in high concentration zones is not a minor inconvenience. It is a documented health hazard confirmed by the National Academy of Sciences in their 1999 BEIR 6 report, which analyzed radon exposure data from 11 major epidemiological studies across North America and Europe. Do not skip this step. Your total material cost for a complete 150-foot earth tube cooling system, including pipe, fittings, screen, cement, and drainage stone, is between $140 and $320. If you rent a mini excavator for the trenching, that runs approximately $250 to $350 for a single day, which is more than sufficient. Your total installed cost is therefore between $390 and $670. A professional central air conditioning installation for the same home costs between $3,800 and $7,500, plus $1,100 to $1,600 per year in operating electricity, plus $200 to $400 per year in maintenance and refrigerant service. In 5 years, you have spent $670 once. The homeowner with central air has spent between $10,300 and $17,500. In 10 years, the gap is catastrophic. Your system still costs $670. Theirs has crossed $20,000 and is approaching its first compressor replacement. This knowledge did not disappear because it failed. It disappeared because it worked. It worked so well that it threatened the single largest revenue stream in the entire building services industry. Your grandparents understood the earth. They understood that a root cellar stayed cool in July because the soil 6 feet below the surface does not care what the thermometer reads at noon. They understood that a properly ventilated crawl space was cooler than any room in the house. They understood that nature had already solved the cooling problem, and it solved it for free. That generation built this country on practical knowledge passed hand to hand, neighbor to neighbor, father to daughter, without a subscription fee, without a service contract, without a corporate middleman extracting profit from every degree of comfort. What you heard today is not a hack. It is not a trick. It is the reclamation of knowledge that was taken from you by an industry that profits from your ignorance. Every time you share this video, you hand that knowledge back to someone who needs it. Every time you hit subscribe, you tell the algorithm that this information deserves to exist. Every time you leave a like, you push this past the suppression threshold that keeps it invisible. Do all three. Not for this channel. For the person sitting in a 95-degree living room right now, staring at a $280 electric bill, who has never once been told that the ground beneath their house is a free air conditioner that has been running for 3 billion years. The next vault opens soon, and what is inside is even heavier than what you heard today.